Alright, so what we're going to do on day 2 of Unit 4, we're going to take a small little pause from related rates, and we are going to look at some interpretation of derivatives. Okay, and this is dealing also with particles in motion. The big thing that I want you to learn from today's lesson are the differences between the position function, the velocity function, and the acceleration function, especially by interpreting the language, if you will, as far as the words that you're given for these types of problems. For instance, we have instantaneous rate of change of position. All of that is pretty much synonymous with what? The derivative, right? So all of this is the same as the derivative. Someone said slope, which is also the same as what function? The position, the velocity, or the acceleration? The velocity. Okay. Okay, again, if you need to write this down, please do so in your notes. Position, velocity, and acceleration. So, possible units of acceleration. I have A, B, C, D, E, F, or G. Look at all of your choices, and you tell me what answers could go with number 2. F, and what else? C. Okay. Let's go with number 1. So let me make just a little bit of room here. From the interpretation of what we just wrote down, what letters could go with number 1? A. Yeah. E. What else? And G. Okay. How about 3? Units of instantaneous rate of change of volume, V of T, where V is measured in gallons and it is measured in hours. What answers could go there? Only G. Would you agree? Okay, so G cannot be number 1. You with me how we're doing this? So that one's gone. So number 3 is G. Let's go to number 4. Possible units for position. Which ones do you see up here that could be position? D, right? You with me? As far as units are concerned? Are there any others? Nope, so D is gone. 5. Instantaneous rate of change of velocity. B, and that is the only thing. So right here is a big thing right now that I'm talking about. The rate of change is the same as the derivative. So the way I want you to see this is anytime you see the rate of change, it's going to be like d something dt. So if we're taking the rate of change of velocity, that would go here. What's the rate of change of velocity? Acceleration. So B would be the answer for number 5. So velocity is the rate of change of what? Position. Okay, good. All right, so possible units of velocity. Say again? E. What else?
That's it.
That's the only thing left? Okay, so 6 is E. So now we have G, B, D. Okay, so since we already took E, we know that number 1 is A. What's number 7? Units for instantaneous rate of change of R of T if R is measured in gallons per hour and T is measured in hours. What would be the answer for this one? C. Yeah. So we're going to take this off so that number 2 is F and the last one is C. Any questions from what we just did? Pretty straightforward, right? Okay. All right, so now what we're going to do is look at the difference between instantaneous rates of change and average rate of change. So right underneath or below, I want you to put the tangent underneath instantaneous, and I want you to put the secant underneath the average rate of change. Okay? So the average rate of change you've been doing, believe it or not, since Algebra 1. It's this right here. Oops. The only difference now is we're going to call it the f of b minus f of a over b minus a. Okay? And the instantaneous rate of change, otherwise the tangent, we know that this is f prime of x. Basically f prime at a specific x value. And what we've learned so far is it's the limit as h approaches 0 of f of x plus h minus f of x all over h as h is approaching 0. The fact that this is approaching 0 but never to hit, this is what creates this instant. Okay? The average has an actual time interval. You with me? So the biggest thing that I would say is, which one does the word at go with? Instantaneous. Yeah. So this is the at moment, at a point in time. You with me? And then the average rate of change has different words to it. It'll be like during, you know what I mean? Or like an elapsed time. So number 1, over the time interval from 2 to 5, you tell me which one is it? Average. And there it is right there, nice and clear for you. Number 2, after 3 seconds has elapsed. Why do you say instantaneous? So after 3 seconds, we could say at 3 seconds at the same, right? So after 3 seconds is basically saying also at 3 seconds. Because if it was a time interval of average rate of change, it would be saying during the 3 seconds. Okay, so, and I might have messed this up on second period, so if you're listening second period, change this. After is the same as at. Okay? So after 3 seconds, in other words, at 3 seconds, it's the instantaneous rate of change. At noon, instantaneous. So during, this is average, over the 12-hour period, average, and when t is equal to 7, instantaneous. So know the difference. I would say again, second period, if you're listening, after insinuates at. Otherwise, it would say during the first 3 seconds. Part 2. Complete the last column in the following table. Be ready, I'm going to call on you individually with the correct units for the derivative of the function given in the first column. Okay? So we are looking at, here's the function, and we're going to derive it to get the primes over here that you see, and we're just trying to get the correct measure. Okay? So the independent variable, which is x, so the input, and this is y, the output, the units for the derivative of c of t is going to be dollars per hour. You with me? Because the unit of time is going to be this dollars per time. Otherwise, what I'm wanting you to know, it's units per time. Guys, if I give you, which I will, on a quiz or a test, a question that I don't specifically tell you feet, minutes, hours, or any unit, do you think I want you to write your answer with this? Yes, I do. Okay, so I want you to do it always, because I always want you to know what units you're working with, okay? If you don't write units, you will be counted off on this test for each time that you don't write them that you're supposed to. So it's a big units test for sure. Okay. Braden, what would the second one be? A of t, where the input is seconds, that's time. The area is square centimeters, and we're trying to find the derivative. What would that measurement be?
Centimeters squared per second.
Yep, centimeters squared per second. And second, use s for uniformity purposes. Please don't use, and I know some of our problems will have this, for second like that. I just don't want you to get that confused with secant. Okay? So just make s for seconds, please. Let's see. W of v, let's go with Taylor. W of v is my function. V is measured, and V is the input, is measured in cubic meters, and W is measured in kilograms. And if I asked you to derive this, how would you write these measurements? Yep, kilograms per cubic meter. We good? Okay. And then last but not least, this one's a little bit confusing. Think about it. M of V, where our input V is measured in miles per hour, and M is measured in miles per gallon. Christian, what would my answer be here? Let's think about this. Here we go. Ready? And I think you might be right. Look, if you don't know this already, this is the derivative, aka the rise over run, aka the y over x. So what we've been doing is putting these y values divided by these x values to get my velocity units of measure. So if I have miles per gallon, and I'm going to divide by miles per hour, again, like we've been doing since the beginning of school, I would write this like you used to do in 5th grade, so that you can keep, change, and flip. So what would my actual units of measure end up becoming? Hours per gallon. Okay, so hours per gallon. You see how that was weird? Okay, so you will have that sometimes. Please make sure that we understand how we're doing this, okay? Any questions?
So we have to figure this out like from the word problem itself.
Yep. Yes, sir.
Is that like even a unit?
It's not even a unit, but the way that it's written, the way we do it, that's how you're going to solve it out. It's the rise over run, otherwise the y over x, because that's the f prime, and that's the way you know what I mean? I just want you to get I want you to understand how this is built to get that ratio.
So even
And-
like the time should usually be at the bottom, it's at top because of the.
Because of the way that it was given here. Yeah. Does that make sense? Okay. So let's think about this. As far as our fractions, if I have 1/3 of something, please write it like this. Units of measure, then reserve those diagonals like that. Okay? So please, for the sake of uniformity, please stop writing fractions like this, because a lot of you sometimes, depending on what else is close to it and next to it, are writing things incorrectly actually. You know what I mean? So let's say that I wanted to write this. I see a lot of people's work that they write it like this. And that's not the same. These two right here, right now, are not the same. Okay? This one over here on the right is multiplying by pi, or pi over 1, is actually equivalent to that. So if you wanted to make them the same, you would need parentheses to make it look like that. So that's what I'm saying. For the sake of uniformity, please make your numeric fractions like this and your units of measure fractions diagonal. Okay. Examples. V of t gives the volume of water in a tank in liters after t minutes. So the volume is the result, time is the input. So this means after 3 minutes, there are 20 liters of water in the tank. Okay? Here, it says after 3 minutes, the volume of the water is decreasing at a rate of 2 liters per minute. If this says -2, why, Jordy, do we not have a -2 right here? Because it says decreasing, and this decreasing accounts for that negative. Okay? What is the most important word on these last 2 lines, would y'all say? Rate. Perfect. Because if it's a rate, if I say volume's rate of change again, you tell me, which one am I talking about? I'm talking about f prime of x. Because volume is a position function level. And when I derive it, it's talking about f prime. You see what I'm saying? You tell me. Let's change volume, Robic, to a word that if I said the rate of change of this word that you're changing this to, then I would get acceleration.
So,
What would I put for volume? So instead of volume, what could I say right here, Robic, that I could take the rate of change of this thing to get acceleration?
wait for the specific problem.
Just we're creating a new one. Like, help him out, guys. What word would go in there? Velocity. So the velocities, a velocity's rate of change is going to be the same as f double prime. Okay? All right. Any questions so far? All right, so number one. A of t gives the area of the surface of an oil slick. Okay? In square kilometers after t hours. Okay, so in square kilometers, t hours. So A of 24 is 17. Okay? You will see this a lot on the AP exam for sure. They're going to give you all these little pieces that look like this, and you have to come up with the context and interpretation. So Omar, let's look at A of 24 is 17. This means after what?
For 24 hours.
After 24 hours. Why did you not say minutes?
It says after T hours.
After t hours. Yeah, it's a different problem. Okay? So after 24 hours, the area of the surface of the oil slick is, anyone, what? 17, say again? Square kilometers. Right? Wait. Oh, that's kilograms. Kilometers squared per.
I did not think you did it because it's not.
That's it. Perfect. So the area, nowhere did it have what word? Rate. There was nowhere where it said the rate of change. So this is position interpretation. And you can also see that because right here it doesn't say A prime. So you're talking about the position function. Okay? Good job on that. So this one is definitely talking about f of x, like we were saying way over here, what we're going to be looking at today. But this one is looking at f prime of x. Okay? Amy, A prime of 5 is equal to 4 means that when what?
5 hours have elapsed during the surface of the oil slick is increasing at a rate of 4 kilometers squared per hour.
Yep, 4 kilometers squared per hour. Oh, I need to put that over here, right? Kilometers squared per hour. And you said it. What goes in this blank? Increasing. How do you know it's increasing and not decreasing?
Because it's a positive change.
Because it's a positive. Because this value is a positive right there. Okay? Subtleties, but huge and very, very important. All right, so that's more of the same. Let's come over here. Let's do number 4. Nate, we have P of t gives you the population in billions of people of the world t years after 1950. So, right now, Nate, is that f prime or f double, or what is that? F prime or f double prime? F of x, yep. So that's position. And it means that in the year what?
1990.
1990, nice. Please use context clues because 40 years after this is 1990. And what do I say after that?
The population is 5.3 billion people.
Yep, the population is 5.3 billion people. No per hour or no per year, none of that because it's a position function. Okay? Matthew, let's go with this one. F of x, F prime, or F double prime? F prime, yeah. So this is the velocity, rate of change. So, Matthew, what would we say here? It means that what?
It means that it was 60 years after 1950.
So in the year, what? What year is that?
I think 2010.
Yep. In 2010, what?
The population is increasing by 0.0
Good. The population increases, or is increasing, like those ing words, because those ing are interpreting like a derivative of some kind, some rate of change, in this case, rate of change of this position. So in the year 2010, the population is increasing, can you say it again, Matthew, at a rate of what?
at a rate of 0.078
Billion people per year. Awesome.
So this is what you mean by the double page.
Yeah, this is pretty much what I'm trying to get to as far as units of measure, guys. And I'm not even kidding. The units of measure are what trip people up, especially on these related rates and particles in motion problems at the end of the year. So on the AP exam, there are 6 free response questions, and this is half of the test. The rest are multiple choice. But the 6 free response questions that you get half of the test on, each of those questions are 9 points. Okay? And because of small subtleties like this, it prevents people from getting all 9 in a lot of respect. Okay, so we just want to make sure that we cover those very clearly. All right, so the other ones are a little bit similar, so that's why I'm kind of just jumping around. And what we decided to do, let me go ahead and put this on the recording, is these packets that we gave you today, if you turn those in, we have about 12 related rates problems that we want you to do by hand and work out. And then you do the Delta Math assignment. All of that is for 5 bonus points on the test. And the reason why we're doing this is because, and we're helping you with a lot of this packet, of course, is because, first of all, this is important information, and Delta Math does not have good enough related rates problems. So we had to give you some that are out of a test prep book. And we're going to give you the answers, we just need you to show us the work. You know what I mean? Alright, so here we go. After 3 minutes, the volume of the water in the tank is decreasing at a rate of 8 liters per minute. So the derivative statement would be this. The only thing that I would change is I would put like liters per minute. Okay? So when 7 minutes have passed, the instantaneous rate of change of water in the tank is 12 liters per minute. Rovik, what would I write here?
So V prime of 7.
V prime of 7. Tell me why you chose to do V. Why did you choose to do V on this one?
Oh, because it's the water is it.
Perfect. And the water is the volume, right? And why did you do prime?
Because it's asking for the instantaneous rate.
So the instantaneous rate of change, that could be V double prime. It could be V double prime. Why is it V prime?
It's not the rate of change of the rate of change.
Perfect. It's not the rate of change of the rate of change, but it's the rate of change of water. And we know water is V. So V is like f of x, V prime is like this, and V double prime would be that. So when I say the rate of change, I'm going to differentiate, I'm going to take the prime of water. So that will give me this, which that's interpreted. Okay? I just want to make sure that, yeah. So what would I get for the rest of it, Rovik?
Equals 12 liters.
Is it positive or negative? It is positive. Why did you say it's positive? It's not saying it's decreasing, and it's not saying it's increasing. It's just saying that the rate of change of the water is this. So the interpretation that you can get from this, guys, is what we talked about last time, is speed. speed will always be positive because it's the absolute value of velocity. Remember that analogy that I gave you as far as going backwards on the highway at 100 miles an hour? They're still going to give you a ticket even though you're going negative 100 because it's a speed limit, not a velocity limit. Okay? Let's look at number 2. Taylor, after 2 minutes, the rate at which the volume of the water is decreasing is 5. What would I write?
Is it V double P? Or is it just?
It's still going to be V prime because it's the rate at which the volume is decreasing.
And then F2.
Of 2 equals
Negative
-5
5
liters per minute. Good. And then, Omar, this last one. When T is 10, the rate at which the volume of the water is increasing at 4.
V prime, no,
Yep, is
prime is equal to 4.
4 what? What's your unit of measure? Liters per minute.
It doesn't say that.
So it's kind of going off of this one still. Okay. All right, so let's move on. Okay, here we go. So this is the big part of what we were trying to accomplish with these notes, or what we accomplished, not what we're trying. The volume of a cone is decreasing at a rate. So all of this with this active ing and rate says that it's going to be a derivative of some kind. This what I highlighted in blue is another way of saying we're taking the derivative. This is the derivative piece. Okay? So if we're taking the derivative of volume of 2 cubic feet per second. Nate, what would I write?
So
I would put d something dt. D what?
dV
dv, yeah. Capital V. Because V represents what?
volume.
Volume. So dv dt is equal to what, Nate?
-2
Why'd you say negative?
because it's decreasing.
Good. What?
Is it
Cubic feet, yeah. Cubic feet per second. This numerator can be feet, it can be feet squared, and it can be feet cubed. All that's representing is one dimension, two-dimensional area, or three-dimensional volume. It has nothing to do with this. You with me? Alright, so let's do the next one. The population of Homer, Alaska is growing at a rate of 3 people per day. Amy, how can I do this? D what? dt.
Can we make up a letter?
You can, yeah. Yeah, so dp, and that's a good choice because that's population. dp dt is equal to 3 people per day. Positive or negative? Positive because it's growing. And the height of a tree is increasing, so it's going to be positive. Guess what letter we use for height? H. So we'll say dh dt is equal to 1/2 foot per year. And the water level, guess what letter we use for water levels? So we actually use H because we're going to do it as height again. Okay, so when you have these kind of problems, like on the cones and everything like that, please use an H as well, okay? And if you use a W, I mean, you'll be fine, but I would prefer uniformity of H. So water level, we'll say, is an H. So it's decreasing, so it's a -2 inches per hour. Just wanted to make sure that we get some really, really good practice with all that. And again, what I will ask you to do for uniformity purposes, these one-dimensional pieces, please use lowercase letters. Anything that is a volume of some kind or an area, please use capital letters. The people can be capital as well. That's fine. Okay? All right. Here we go. Given the following symbols, try to determine what they might mean. I think this one's easy right off the bat because we kind of did something just now on it, right? What does this mean?
Area
The area is
decreasing at 4 feet squared per second.
perfect. Decreasing three more words after that. Decreasing at a rate. At a rate. At a rate, you're going to see this a lot. Okay? Of 4 square feet per second. And again, guys, please use S for seconds because this is going to confuse you in some respects, and I don't want you thinking secant. Okay? So please just use S for seconds. Let's do number 6. Jordy, what does that look like? Yeah, nice. This is surface area. We know it's area because of this. Yards squared gave us the hint that it was two-dimensional. So it's an area of some kind. And we're going to say that the surface area, keep going, Jordy, increases So, yep, is increasing at a rate of, one more time? Perfect. And then this one right here, real quick, this could be like circumference. This could be, what do you think? Radius. And what do you think this one is? The volume. Cool. All right. So now let's go and keep moving on. What I want you to do is we have to remember that we are differentiating in respect to time. That means our variables are going to change. And we just saw a lot of variations with those variables just now. R, H, V, S, whatever it is. So what I want to do is get a little bit of practice on these next 3 slides of differentiating ones that you think might be difficult. Okay? Which ones do you want me to do from this slide? Pick 2. 4. What else? 3. Here we go. So the derivative in respect to time is going to be 2a dA dt. Now you help me. Yep. Plus what? 2b dB dt. Nice job of not forgetting that. Equals 2c dc dt. Yep. So guys, whenever I gave you a picture, I think it was of number 9 of your homework, that one where the boat is being pulled in with that winch, I'm wanting you to find dx dt, the acceleration. Couple things on that. I had something, and I'm just kind of summarizing the piece that we made a mistake on. If I saw this, but I saw it as a product, so let's say that I saw it like this, like that. And if I were to differentiate this and said, this is my first, this is my second, and I did a product rule, 2r, so the first times the derivative of the second, I'm taking the acceleration, plus the second times the derivative of the first. Guess what mistake I made on that picture that I sent you yesterday? What do you think I put at the very end? I just put 2. So again, this is the first, this is the second. So if I differentiate it product rule, I say first times the derivative of the second, plus the second times the derivative of the first. What should I put? 2 dr dt. So 2 dr dt. So yesterday I sent you a picture and I only put 2, but then I fixed it and I sent you the other picture, okay? So please take a look at that. I just want to make sure we're not forgetting that. Number 4, I would concentrate on all the pieces that I know are constants. And I'm going to use the constant multiple rule. and I'm going to differentiate everything else. So ds dt, and there's a product rule now with r and h. Y'all help me out. What would I write down for r times h differentiated? Yeah, r dh dt plus h dr dt. Nice. How about for this other one? Nice, guys. You guys are killing it. You're doing well. Yes, multiplication in between all those pieces for sure. All right, so now let's look at two examples from here. Which two would you like to do? 8, and what else? I would say the other ones are pretty similar to what we've already done, right? Okay, so 8. I'm going to get this constant all together and differentiate all the other variables. So on the left I have dv dt, and here's another product rule between r squared and h. So we have first times the derivative of the second plus the second times the derivative of the first. So multiplication exists all there, and that's another product rule that we have as far as those two product pieces that are in my equation right here. We good? Okay, so let's keep going. I would say, yeah, let's do one from here. Which one do you want to do? 15? Okay, so 15, 1/2 is our constant. So we're going to say dA dt is equal to our constant times the other product rule, because those are variables. So we're going to do a product rule. Here we go. The first times the derivative of the second plus the second times the derivative of the first. And that would be the derivative. Please make sure of correct parentheses usage for sure. Okay. Here we go. Here we go. Let me start a new video.